Okay, we're going to be looking at the Fibonacci numbers symbolically. So here we have, this represents the nth Fibonacci number. If we say n equals 5, then what we would do is we'd be substituting in 5 for n here. We would have f sub 5, which actually ends up being the fifth 5. And this right here, this f of sub n minus 1, that is the term before the nth number. And since n is 5, if I substitute, 5 n for 1, where I have 5 minus 1, that ends up being 5 minus 1 is 4. So we're talking about the fourth Fibonacci number, which is 3. And then again, we're just going to follow the same process. N equals 5. So this is f sub n minus 2. That's talking about 2 terms before the nth term, which would mean 2 terms before, if I substitute 5 minus 2, put 5 is for n, that's the third Fibonacci term, which is 2 terms before, and the third Fibonacci number ends up being 2. And I just continue this process. The n equals 5. This represents the 3 terms before, 1, 2, 3 terms before the nth term. 5 minus 3 would equal f sub 2, which ends up being 1. The second Fibonacci number is 1. And then lastly, this represents 4 terms before the nth term. So 1, 2, 3, 4, which would be f 5 minus 4, which would end up being f sub 1, which means the first Fibonacci number is 1. So here we go, the Fibonacci sequence, 1, 1, 2, 3, 5. The same is true if we go this way. This plus 1 is talking about the term after the nth term. So the term after, the fifth term, would be, the sixth term, but let's look at why it's 6. Well, if we put we put 5 in for n, and we add 1 to it, 5 plus 1 is the sixth term, and the sixth term is 8. And then, this plus 2 represents 2 terms after, 1, 2. So 2 terms after the fifth term would be the seventh term. Well, that's because we're going to go 5, put 5 in for n, add 2 to it, and we get the seventh term. And the seventh term in the Fibonacci sequence, would be 5 plus 8, which is 13. And then plus 3 would be 3 terms after, 1, 2, 3, which would be, we'd put 5 in for n, 5 plus 3, that would end up being f of 8, which would be the 8th term, would be 8 plus 13, which ends up being 21. And then we do, 4 terms after, that's what plus 4 means, so 1, 2, 3, 4 would be 5 plus 4, which is f of 9, and the 9th Fibonacci number is 34, or 13 plus 21. And then lastly, this n plus 5 would be 5 terms after the nth. 1, 2, 3, 4, 5. So f of 5 plus 5 equals f of 10, and the 10th Fibonacci number is 55. Now, it's really important to see how all of these Fibonacci numbers are related to actual numbers and symbols. Now, these symbols can represent anything. I'm just having them represent these particular numbers in the Fibonacci set for this example. But if you see here, we actually have the Fibonacci, the equation for the Fibonacci numbers right here. F sub n equals the term before it, f of n minus 1, plus the number that's 2 terms before it. If you take the number that before it and you add it to the number that's 2 terms before it, that's how you get the nth number. If you see here, the term before 5 is 3, 2 terms before is 2. If you go 2 plus 3, you get 5. Okay? Now, this same definition can really be applied for any scenario. If I want to figure out, well, what is the 3 terms after the nth number? So if I have f of n plus 3, well, how do I get f of n plus 3? Well, how do I get 21? 21 is made up of 8 plus 13, or f of sub n plus 3 is made up of f of sub n plus 2, the term before n plus 3, and you add that one to the one that's 2 terms before n plus f sub n plus 3, which would be f sub n plus 1. That's how you come up with f sub n plus 3, is adding f sub n plus 1 plus f sub n plus 2, and that's how you get that one. If we wanted to, figure out, well, how do you get f sub n plus 5? Well, f sub n plus 5 is made up the term before it. Well, what's the term before it? Well, it's f of sub n plus 4, and then you add it to two terms before f sub n plus 5, which would be f sub n plus 3. If you go f sub n plus 3 plus f sub n plus 4, you end up getting f sub n plus 5, which is true because you look at the numbers. 21 plus 34 is 55. So you're going to have some problems, and where you're going to have to manipulate the problems. They're going to say, well, what is f sub n minus 4 plus f sub n minus 3? Well, I know if I go f sub n minus 4 and I add it to f sub n minus 3, well, what am I going to get? Well, I'm going to get f sub n minus 2. Because if I take the term before it and add it to the one that's two terms before, I get this one right here. So 1 plus 1 is 2. So it's just a different way of really using this same idea, the same recursive equation, but kind of just tweaking it a little bit, and you get the same identical thing. So you're going to have some problems like that. You're also going to have some problems like this, which take the original Fibonacci sequence. So if you want to figure out the nth term, you add the one before it to the one that's two terms before it, right? Well, what happens, right now this equation is solved for, the nth Fibonacci term, but what if we solve it for the f sub n minus 2, the one that's two terms before? Well, if we want to isolate this f sub n minus 2 and get it by itself, we have to get rid of this one. Well, how do we get rid of it? Well, we use we just use some simple algebra. We use the inverse operations. We see how these are related. These two terms are related through addition. So we're going to do the inverse operation of addition, which would be subtraction. And whatever we do to this side, we have to do to this side. So what we end up doing is when we isolate f sub n minus 2, that is equal to the nth term minus f of n minus 1. It's just a different way of looking at it. You might have a problem that says, well, what is f of n minus 1, or f of the nth term minus the term before the nth term? Well, that's just a manipulation of this original formula, and it's f sub n minus 2. Another type of equation that you might have is something like let's say instead of this one, we take f of n plus 2. Well, what makes up fn plus 2? Well, what makes up fn plus 2 is the term before it, which is fn plus 1, and you add it to the one that's two terms before it, which would be the nth term. Well, let's say we solve this equation for f sub n plus 1. Well, to solve it, we have to get it by itself. We have to get rid of this nth term. So the nth term is related to this through addition. We're going to do the inverse operation of addition, which would be subtraction. So we're going to subtract the nth term to both sides. And what we end up with is f sub n plus 1 equals f sub n plus 2 minus the nth term. Now you might be given a problem that says, what is f sub n plus 2 minus the nth term? And you would need to know how all these are related. You need to know that it's f sub n plus 1. Now another example that you're going to get into, which is a little fun, it's kind of like a puzzle, is something like this. So you're given the nth term plus f sub n plus 1 plus f sub n plus 3 plus f sub n plus 5 equals f sub what? We have to figure out what that equals. Well, we're just going to do a little puzzle here. So let's just focus on these two right here. Well, what is the nth term plus f sub n plus 1? If I take this term and I add it to this term, what do I get? Well, what I get is f sub n plus 2. So all of this really equals, f of n plus f of n plus 1 equals f sub n plus 2. And that's what that equals. And then I'm just going to rewrite this other stuff. And now I'm here. Well, now what do I see? I see f sub n plus 2 plus f sub n plus 3. Well, what do those two? It's kind of like a puzzle. Well, what do those two equal? If I go f sub n plus 2 and I add it to f sub n plus 3, what do I get? Well, when I add those two together, I get f sub n plus 4. So now these two, when I add those together, they become f sub n plus 4 plus f sub n plus 5. And now I'm left with these two. Well, f sub n plus 4 plus f sub n plus 5. What is f sub n plus 4 plus f sub n plus 5? Well, when you add those two together, you would get the next term in the sequence, which would be f sub n plus 6. That's what these two equal. So if you get a problem like this, the answer, what you'd put in here, would be the n plus 6. That would be the answer.